Hello good day viewers. In this tutorial we want to show that n to the power of 3 plus 2n is divisible by 3 using mathematical induction, where n belongs to the set of natural numbers. Though I have not treated mathematical inductions before, but we can use this particular example to explain mathematical induction. What is mathematical induction? Mathematical induction is just a technique used to prove whether a mathematical statement is true in the set of natural numbers. So let's get started. If at all n to the power of 3 plus 2n is divisible by 3, how can we prove that? We have 3 steps. The first step is to test n equal to the first term of the natural numbers, which is 1, to see whether it is divisible by 3. If it satisfies, then we test for other terms. So when n is equal to 1, that is the first step. We're going to test for n equal to 1. So this becomes 1 to the power of 3 plus 2 multiplied by 1. Is this divisible by 3? That's the question. You know, 1 to the power of 3 is 1 plus 2 multiplied by 1 is 2 divided by 3. No doubt 1 plus 2 is equal to 3 and 3 divided by 3 is equal to 1. So this is equal to 1. This implies that 3 is divisible when n is equal to 1. So having seen this, the next step is to assume other certain numbers will satisfy. So we assume we also assume it is divisible by 3 when n is equal to k, where k also belongs to the set of natural numbers. So we are going to substitute n equal to k. So we are assuming that k to the third power plus 2k is also divisible by 3. Let this be true. If it is true, remember this is the second step. Let me write it here. Second step. This is the second step. We test for k equal to n. So what is the third step? The third step is to replace k with k plus 1. What does that mean? If k is a certain number, for instance 2, if 2 satisfied, we assume 3 also satisfied. And that will be 2 plus 1, meaning k plus 1. So let's assume that also k plus 1 will also satisfy this problem. So step 3. We want to prove that it is also true for some k plus 1. So instead of k, we replace k with k plus 1. So we want to show that k plus 1 to the third power, replacing k with k plus 1, plus 2 multiplied by k plus 1 is also divisible by 3. We want to show that this is true. So let's expand this. If you expand k plus 1 to the third power, you're going to obtain k to the third power plus 3k squared plus 3k plus 1. This is the expansion of k plus 1 to the third power. Then if you distribute 2 over this, you're going to obtain 2k plus 2. We want to show that this is also divisible by 3. But observe from what we have done earlier, we have seen that k to the third power plus 2k divided by 3 is divisible by 3. And observe that we have such terms here, k to the third power plus 2k. So we can bring them together. So we have k to the third power plus 2k. Then let's group this together, then plus the other terms. We have 3k squared from this plus 3k. Then you see we have 1 plus 2 equal to 3. So we have plus 3. Divide by 3. We are still proving. So we can split the fractions, right? If you split the fractions, you have k to the third power plus 2k divided by 3, right? Then plus the other one, 3k squared plus 3k plus 3, also divide by 3. Already we have seen that this is divisible. We have seen that this is divisible earlier, and this can be factorized. We can factorize it as 3 multiplied by k squared plus k plus 3, or plus 1, sorry, if you factor out 3 outside, and this is divided by 3. And you can see 3 will cancel 3. This implies that it is divisible how many times? K squared plus k plus 1 times. This is equal to k squared plus k plus 1 times if you divide that by 3. And since this is divisible, this is also divisible, we conclude that therefore n to the third power plus 2n is divisible by 3. Hence proved. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.